Hello everyone, welcome to the series of the USCIS Coding Challenge application video walkthrough. In this channel, you are going to see how Anika Vital team prepares, designs, and implements a system with application and infrastructure components and pack the solution to meet the customer's requirement. In the previous sessions, we have covered the requirement analysis and service component selection. Today, we'll take a look at the integration between those components. I wish it does not only explain how our team completes the tasks, but also give you an idea on how to choose the appropriate technologies to meet your customers' requirements. For today's session, I divide the content into 3 parts. We will start with the integration between Web UI and Backend API using API Gateway. After that, we will look at managing database schema and handling data insertion via application code with Hibernate. We will end this session by allowing components to communicate through asynchronous messages with ActiveMQ. Okay, let's get started with the API Gateway. API Gateway plays the role as a powerful mediator between the application's frontend and backend in USCIS Coding Challenge, enabling seamless integration. Here is how API Gateway facilitates this process. Unified endpoint for frontend. API Gateway acts as a single entry point for all API calls from the frontend, simplifying the integration. Instead of directly invoking multiple backend services, the frontend communicates with the gateway. Routing and load balancing. It routes incoming requests to the appropriate backend services based on the URL path or other parameters. It also supports load balancing, ensuring high availability and optimized performance for backend services. Authentication and authorization. API Gateway can enforce security protocols like OAuth, API keys, or IAM roles. It also protects backend services by ensuring only authenticated requests reach them, removing the burden of authentication logic from the backend. Request and response transformation transforms requests and responses to match the requirements of the frontend or backend. For instance, it can modify JSON payloads or map HTTP requests to specific backend service protocols, such as from HTTP to WebSocket. CORS management. API Gateway simplifies the handling of cross-origin resource sharing, which is essential for browser-based applications interacting with APIs hosted on different domains. Rate limiting and throttling. API Gateway protects backend services from being overwhelmed by limiting the number of requests a user or application can make within a specified timeframe. Caching. API Gateway reduces latencies and enhances performance by caching frequent API responses, especially for read-heavy applications. Monitoring and analytics. API Gateway provides built-in tools for logging, monitoring, and analytics. For instance, AWS API Gateway integrates with CloudWatch for tracking usage metrics, error rate, and latency. These insights help in troubleshooting and optimizing the backend. Multi-protocol support. API Gateway supports different protocols like REST, WebSocket, and GraphQL APIs, making it versatile for different application architectures. Decoupling frontend and backend. API Gateway enables independent development and the scaling of the frontend and backend. The frontend doesn't need to know the internal structure of backend services, as the gateway abstracts these details. In USCS Coding Challenge, by introducing API Gateway, the frontend, which is the React Web in our case, sends HTTP requests to API Gateway. API Gateway routes those requests to specific backend services, including the AWS Lambda and Spring Boot API. Then the backend sends the responses back to API Gateway, which forwards them to the frontend, optionally transforming them to meet frontend requirements. By offloading various responsibilities to API Gateway, we can focus on building robust frontend and backend services without worrying about integration complexity. Now we have a solution for front-end communication. Let's take a look at the database layers integration using Hibernate. Hibernate is an object relational mapping framework for Java, which provides robust tools for managing database schemas and handling data insertion via code, particularly when interacting with APIs. Hibernate simplifies database schema management through a feature called Hibernate Schema 2, the DDL Auto. This feature can automatically update your database schema based on changes in your entity classes. Schema Auto Update. Hibernate analyzes the entity classes annotated with @entity and updates the database schema accordingly, such as adding new tables, columns, or constraints. Control via hibernate.hbm2ddl.auto. This configuration in application.properties or application.yaml defines how schema updates are handled. Validate validates that the schema matches the entities but does not make changes. Update automatically updates the schema to match the entities. Create drops and recreates the schema at every start. Quit drop the schema when the session is closed. None disable schema management. Caution: in production, it is generally advised to avoid using update or quit drop to prevent accidentally data loss or unintended schema modifications. Instead, we may want to go with controlled migrations. When integrating with APIs, Hibernate helps to seamlessly mapping data objects to database tables and managing persistence. There are a few benefits of doing so. Automatic mapping. Hibernate takes care of SQL generation and object table mapping, reducing boilerplate code. Transaction management. It integrates well with Spring's transaction management, ensuring atomic operations. Batch operations. For bulk API data, Hibernate can optimize insertions with batch processing. To begin with data insertion, we need to set up entity mapping first. Define the database table structure in Java classes using Hibernate annotations. Then we will be able to fetch data from API, using the API client to retrieve data and map it to our entity class. Finally, we also want to persist data. Use Hibernate Session or Spring Data JPA repository to save the data. In addition to the synchronized API call, we also have the asynchronous message queue using ActiveMQ. ActiveMQ is an open source message broker that facilitates communication between distributed systems by sending and receiving messages asynchronously. It follows the Java Message Service specification, enabling applications to decouple the sending and receiving of data, which improves scalability and flexibility. ActiveMQ consists of three parts. The message producer is responsible of handling messages to destinations, such as a queue or a topic. The message broker routes the message. The message consumer retrieves a message from the destination. ActiveMQ supports different messaging models. The point-to-point model, which is also called queue, is a single message consumed by one receiver. The publish-subscribe model, also known as topics, is a message that delivered to multiple subscribers. There are plenty of benefits to use ActiveMQ. Asynchronous communication allows components to communicate without waiting for each other to process messages and enhances system responsiveness and resilience. Decoupling of components. Producers and consumers can operate independently, reducing tight coupling in distributed systems. Scalability. Handle high throughput by distributing workloads and managing message queues effectively. Reliability ensures guaranteed delivery of messages with features like persistent messaging and acknowledgement mechanisms. Flexibility supports multiple messaging protocols such as MQTT, STOMP, AMQP, and compatible with various clients written in different programming languages. Fault tolerance provides clustering, failover, and high availability setups. Message filtering and routing includes mechanisms for filtering messages based on selectors and supports advanced routing for targeted message delivery. Transaction support allows transactions for processing multiple messages in a unit of work. Open source and community support. As part of the Apache project, ActiveMQ is well documented and supported by a strong community. The typical user cases include enterprise integration, connects disparate systems in an organization. Event-driven architecture handles events in microservices-based systems. IoT applications streams data between devices and services. Order processing systems queues orders to ensure they are processed in the right sequence. In summary, ActiveMQ helps to build resilient, scalable, and lossless coupled systems by simplifying communication between components. That is all about the data flow and integration points in USIS Coding Challenge. I hope you learned something new today. Thanks for watching and see you in the next video.